All right, my job is to simplify 6 minus 2i, 2 plus 4i. And you might be looking at this and thinking, well, okay, there's a 2 in common, so let's take care of that. So let's bring out a 2. That's 3 minus I over 2. That's 1 plus 2i. Cross you out, and you now have 3 minus I over 1 plus 2i. And you might look at that and be like, done. We're not done. There's an issue here. I is the square root of -1. And last time I checked, you can't have square roots in the denominator of a fraction. So the way we're going to handle this is we're going to multiply the top and the bottom by what's called the conjugate. This is basically a difference of squares problem that eliminates all possibilities of having square roots or i's on the bottom. So the conjugate is whatever the bottom is, but flip the middle symbol. So 1 minus 2i, 1 minus 2i, multiply the top and the bottom by that. So we have a FOIL problem upstairs. We have a FOIL problem downstairs. But the FOIL problem downstairs is going to make us happy. Upstairs we have 3 times 1. We have 3 times -2i, so minus 6i. We have -1 times I, so negative I. And we have -1, or negative I times -2i, which is positive 2i squared. That's going to be all over. 1 times 1, which is 1. Minus 2i plus 2i disappears. That's supposed to happen. Minus 4i squared. So let's combine the two like terms upstairs in the numerator. So 3 doesn't change yet. This becomes -7i. And 2i squared, remember, I squared is the same thing as -1. So 2i squared is the same thing as 2 times -1, which is the same thing as -2. So that'll simplify. Similarly, on the bottom, we have 4i squared, which is the same thing as 4 times -1. So that becomes plus 4. On the top, these combine to 1. So 1 plus 7i. On the bottom, this just turns into a 5. And some teachers want you to split this up and say this is 1/5 plus 7 over 5i. So now it's in the appropriate imaginary complex form. But that's our guy. Now I, or a square root, is no longer in the denominator. Everything's the way it should be, and that's my answer.